Okay, so I just wanted to compare the flow of electricity with the flow of a fluid. And so in the right-hand column is the electrical stuff, and then in the left-hand column is going to be the fluid stuff. So the first thing I wanted you to compare is how do we measure the flow? So the flow of a fluid is going to be the volume of the fluid divided by the amount of time it takes for it to flow. So that was the volume flow rate up here. When it comes to electricity, it's the flow of electric charge in a certain amount of time, and we called that the electric current, and it was measured in amps. So if you don't remember this, then go back to lesson 21 where we talked about all of this. Okay, then what is it that causes a fluid to flow? Well, we said that it was pressure P, but you could also say it's because it's trying to go from high potential energy to low potential energy. Just like this thing drops when I let it go, it's going from high potential energy to low potential energy. Another reason is it's in a gravitational field of the Earth. And so again, that's the reason why water will tend to flow. So in similarly with electricity, there was it wanted to go from high voltage to low voltage, and then also it was in an electric field. But the point is, pressure is the thing that causes fluids to flow, and then voltage is the thing that causes electricity to flow. Okay, then you had, what is it that slows down the flow of a fluid? So we call that fluid resistance, and notice that it depended on R, the radius raised to the fourth power, which is going to be basically the area squared. Now notice that this time it's a little bit different, because if you look at the formula for electrical resistance, you notice it does depend on the length of the wire, just like the flow of a fluid depends on the length of the pipe. It also depends on the area, but notice that in the case of electricity, it's area raised to the first power, whereas in the case of a fluid, it's area squared, basically. And then in the case of electricity, it depended on the electrical resistivity. And in the case of a fluid, it depended on the viscosity of it. Okay, and then let's put it all together so that pressure, the pusher of a fluid, depended on the volume flow rate, and then it depended on its resistance. And then in the case of electricity, instead of pressure, it was voltage. Instead of the volume flow rate, it was current. And then instead of fluid resistance, it was electrical resistance. Okay, let's take another break, and when we come back, let's take a quiz over what you learned today.